Hello and welcome to another edition of Sparky Help, and this one is how to complete an electrical installation certificate. Well, it's not that difficult really if you know what you're doing. Electrical installation certificates are only issued in various situations, basically consists of this 2 sheets of paper with 2 additional sheets which get added to it. It's a breakdown as such. So we're going to look at it bit by bit. Electrical installation certificates, as required by the latest edition of BS 7671. Obviously there's a new edition about to come out, so this may well change. So details of client and installation address. Well, the client is the person who you are particularly working for, not necessarily the owner of the house. Obviously installation address is very important because that happens to be where you're doing your test and inspect. So obviously I don't need to go through that. The person who ordered the work, their client for that particular one. Installation address, obviously the address where you are doing the testing, whatever that happens to be. Description extent of the installation. Well, that's a position for you to say what it is you're actually doing. So we'll put it down in this particular case. We've got to do something. We'll base this one on new domestic installation. Extent of the installation covered. Well, this is where you get to break it down. What is it you are actually testing? Because you might have done the whole installation. You might have only done a new bathroom, a new circuit, a new extension. So this is your opportunity to put that information down so your certificate only covers the work that you have done. Which then leads us to the tick box to the right hand side. What do we need to put in? Well, if we looked at BS 7671, it gives us ideas on, well, it doesn't give us ideas, it tells us what we should be putting in. So from BS 771, and it's Appendix 6, it says the electrical installation is used only for initial verification of a new installation, for the alteration or addition to an existing installation, or where new circuits have been introduced, or the replacement of a consumer unit stroke distribution board. So each of those, whichever it happens to be, you tick off. Hopefully as you were watching that, it was ticking it off for you. So we're going to base, as we said already, on a new installation. So we'll just leave that particular one ticked. Let's move on to the next part. So broken down now, we've got this first signatory is required by the person who has designed the installation. So it says we being the persons responsible for the design and installation. Are you a designer? Well, yes, if you've made up the job from scratch, so someone has asked you to come and put some extra lights in or sockets in and no one has told you what to do, then effectively you are the designer. You have decided all the types of cable, the protection and everything, and where everything's going to go, so you are that person. If you've been given a design brief, specification and drawings, then someone else has done the design for you and they would be required to sign this bit off. On some predicted jobs this can be quite large, hence we have 2 signatories on here, but it can only be one person. So what do we need to put in here? Well, there's a little bit at the very beginning. It says you're going to certify that the work, and to the best of their knowledge, is in accordance with BS 7671, and this particular one is 2018 and amended to the correct date. Now obviously it depends what amendment you're working to, and obviously there's a new one about to come out and we shall see what the outcome is on that particular one. But whatever you've amended it to, let's bring you right up to date, and this probably isn't going to be as accurate, so you'd look at whichever version you've gone to, and on here we can see that it is Amendment 22, which comes out later on this year, and so it is 2022 is the year that goes in there. That's easy enough, that's straightforward. Next bit down, details of departures from BS 7671. BS 7671, remember, is guidance only ultimately. It's only in a court of law where it would be tested against you, used as evidence. So it says it's got details of departures from BS 7671, regulations 120.3 and 133.1.3 and 133.5. So let's have a look at each of those and see basically what are they referring to. So 120.3, this standard sets out our technical requirements to enable electrical installations to conform with the fundamental principles of Chapter 13, as follows. So basically it's saying it's got to follow Part 3, 4, 5, 6 and 7 of the regulations. So The installation's got to comply with everything to do with that. But as the last bit at the very bottom there, any intended departures from these parts requires special consideration by the designer, which remember could be you, of the installation, and shall be recorded on the appropriate electrical certification specified in Part 6, i.e. what we've just been looking at. The resulting degree of safety of that installation shall be not less than that obtained by compliance with the regulations. So basically whatever you put in, if it's deviation from the regulations, it's got to be equal to the standard that the regulations said in the first place, or higher. Obviously you could always go lower, but remember that could be used against you. The next regulation it referred to, it says 133.1.3, it says where equipment to be used is not in accordance with regulation 133.1.1, or it is used outside the scope of the standard, the designer or other person responsible specifying the installation shall confirm that the equipment provides at least a degree of protection. So like I say, whatever you put in has got to be equal to or above whatever the rest of the regs that you've deviated from says. For example, and this is only an example, if it said a particular enclosure had to be IP2X and you decided to go, no, I'm going to put some weird thing in, I don't know what you'd put in, it's got to be at least IP2X that you put in. If it doesn't specify on it, you'd have to get it, make sure that it does check that, which is basically a little finger ultimately. The next one on there then, 133.5, it says new materials and inventions. Why you're making new materials and inventions, you might be, I don't know. There are lots of things that are constantly coming onto the market, but hopefully the manufacturer do actually test and check them for you, and therefore they do comply. But if you didn't, then it would be your responsibility to make sure that it does meet the requirements. And it says where the use of materials or invention leads to departure from regulations, the resulting degree of safety of the installation shall not be less than that obtained by compliance with the regulations, and it must be recorded on the test sheet. And that's the bit we were just looking at. So the general gist here is, if you do deviate from the regulations, whatever that happens to be, whatever you replace it with, it must be equal to or higher what the regulations asked for in the first place, and you must record it on the test sheet itself. So that's that first little bit. There's a little bit straight underneath. It says details of permitted exemptions, and it takes us to chapter 41 of the regulations, 411.3.3. Where applicable, a suitable risk assessment must be attached. This bit, I believe, is going to go in the next regulations, but this particular one says additional requirements for socket outlets for the supply of mobile equipment for use outdoors in AC systems. Basically, you've got to put an RCD on it, a 30 milliamp. And the top one there, number 1, it says socket outlets with a rated current not exceeding 32 amp. And it says under the very bottom, it says an exception to number 1, i.e. the 32 amp one, is permitted where, other than for an installation in a dwelling, so that's a domestic installation, a documented risk assessment determines that the RCD protection is not necessary. So if we were in a commercial installation, you had 32 amp sockets, the top bit of the regulation basically says you should put a 32 amp breaker on it, or protective device, so up to those size, and it should have a 30 milliamp RCD. You could choose not to. If you choose not to, you have to then attach the corresponding risk assessment deeming why you've felt it necessary that you do not need it. Why you'd bother going to these lengths, I do not know. So you're probably just easier just to put it in and save yourself some unnecessary paperwork. So in our case, what we would probably be looking on here then is none in this particular case, and none in this particular case here, because we're not going to, because we've already said it's domestic, so it wouldn't apply to us in the first place. And then obviously once you've designed it and you're happy with it, obviously you would then sign it, whoever that happens to be. I mean, you don't need a video to tell you how to sign something and put your name and address on something, but we're going to anyway. It's then broken down for construction. Construction does exactly the same. It's slightly fewer regulations on this particular one, but it's basically asking what construction, what amendment you've installed it to. So we'll just go completely up to date, try and future-proof myself, but I probably won't be, because I'll be undoing myself and I'll end up doing this again. And any details of departures, the designer has said what they're going to do. Have you installed it as per the design? If you have, then it will be none as well. And obviously once you've installed it and you're happy with it, you would then sign it. We then have the third person who could actually be signing this paperwork, and it says for the inspection and testing. Similar as before, which version are you testing to? So presumably if it's been designed to 2022, then obviously you would want to test it to 2022 standards. So you would put that date in. Are there any departures whilst you're inspecting from what you have seen? And hopefully it would also be none. Once you are happy with your all installation, obviously the important part from the client is they would like a signature and they would like the paperwork handed over. So obviously that would go in. The next inspection. When would we carry out the next inspection, or when do you advise the next inspection to be carried out? And it notes on here it is not the inspector. Okay, it is the designer, which may well be the same person, remember, but it's the designer who recommends when the next periodic inspection will be carried out. There is guidance we can go to, and that would come from guidance note 3 ultimately, or anywhere else, any other legislation that might come in. It might be an insurance company and might drive this, but you're ultimately, or the client itself might prefer a particular figure. But if nothing else, we can go to here and have a look at this. And so domestic installation on here, routine checks, nothing in particular, but maximum periodic inspections between testing is 10 years. Remember, these are recommendations. No one's going to make them do it, or it's unlikely unless there's a law change for domestic installations. The people who tend to make these happen would be people like mortgage companies or insurance companies, and that goes the same for commercial and industrial as well in most cases. The bit to note on that one is rented out, because they now have legislation that has come into play where it does have to be tested, and this particular set of regulations says that it must be tested and inspected at regular intervals by a suitably qualified person, which is always the case, no more than 5 years, and this I got from the IET on their particular website. So what are we going to put in? Well, we'll go for the recommendation, but you could put anything less, and obviously it would depend on the condition of the installation, how well the environment is. Is it a harsh environment? Is it not a harsh environment? Because if it was a harsh environment, you may want to say every 5 years or every 3 years. So if it was a workshop and obviously construction sites, places like that which all have electrical installations in, there's no point on a construction site saying 10 years, because it would have long gone since then in most cases, unless it happens to be Crossrail, of course. And so therefore we're going to put in 10 years and obviously delete the months, because that's our recommendation. No one probably will, but we put it in anyway. Now that's quite a lot to write for those 3 different things, but there might see other versions out there, because it allows us to get rid of those 3 signatures and replace it with this wording instead. Because remember, the design, construction and inspection could be by one person, so you may see different versions of this particular sheet, not with 3 signatories on, but just the one, because it's you who's doing it. But either way, you're going to put the year that you put it in. We then turn over that page, or on the back of that page, and next page on. The first bit up there is particulars of the signatories. Well, that's not, don't have to be rocket science to work that one out. Whoever signed it, we need some sort of contact details for them. So should anybody wish to contact them, and they would be able to. Remember, these would be made available and handed to the client once finished. Then we get to the bones of the certificate itself, and this is the characteristics and earthy arrangements of the installation and all the details about that installation. So let's work our way through. Let's look at earthing arrangements. Earthing arrangements, I have completed a video, so if you're not sure about your earthing arrangements, go look at my video on earthing systems. But we'll just quickly look at the 3 main ones. This one, I hope you can all recognise, is a TNCS. This one is a TNS, and this one is a TT, because it has an earth electrode. Obviously it would be exactly the same if they were 3-phase, just things are bigger in general for that, and you may not be on such small scale, but the principle is the same. So we'll base it on one, and we'll base all of this. You need something to base it on. So here's that bit of information we're going to keep referring to whilst filling in. We've got a new domestic installation, has been designed, installed and inspected. The intake equipment and earthing system can be seen in figure 1. Figure 1 I will now show you. Figure 1, this then is our earthing system. We now know then that this is a TNCS, so we can tick it off. That's our first bit. Moving on to we'll work our way across, be fairly logical in this. Number and type of live conductors. As you can see on there, we've got AC and DC, but let's look at the wording first of all, because this can throw some people. Number and type of live conductors. A live conductor from BS7671 says see live part. Why? I don't know, but anyway they do. So live part, a conductor or conductive part intended to be energised in normal use, including the neutral conductor. But by convention, not a pen conductor. And a pen conductor, go look at earthing systems, you will find out what that is. So this has come from part 2 of BS7671. That's what a live conductor actually is. So now we know it consists of the line conductor and the neutral conductor. We can basically look at an installation. So the vast majority of installations you would use would be an AC, and hopefully we can see that up there. We got 1 phase 2 wire, that would be a single phase installation. And if we were doing a normal 3 phase installation with a neutral, we would be ticking 3 phase 4 wire. 3 phase 3 wire would be without a neutral. 2 phase 3 wire, you've got 2 phases and a neutral, so some properties may well have 2 phases coming in. Maybe the incoming single phase wouldn't have been big enough because they're miles down the end of a track or something like that, but if you do have it, we've got the availability. So we're going to base ours on AC. We had a single phase installation, so it'll be 1 phase 2 wire. Let's look across to the next bit then, nature of supply parameters. The first one it asks for is nominal voltage, and we have these letters in here, U/U0, which says number 1 if you brackets beside it, and it says by inquiry. I would suggest if you're doing this in by inquiry, probably don't be looking at doing the testing yourself, because you're probably not that competent unless it happens to be abnormal. But let's go look at what U means. U from part 2 of BS7671 means voltage between lines, and obviously that's measured in volts. UO is a nominal AC, RMS or ripple free DC line voltage to earth. So it's a line to earth voltage. So in a single phase installation, that would typically be, for the UK market, would be 230 volts. A 3 phase installation, yep, that's, you guessed it, UO would still be 230 volts because it's a line to earth. So if it was a 3 phase installation, what you'd be writing would be 400/230, but ours isn't, as is a single phase installation, so all we're going to write is 230. And nominal frequency is the next one down there. Hopefully that should all be, and because it has to be within 1%, so that's half a hertz either way, is what the national grid have to keep the frequency within, and therefore that will be 50 hertz. It's prospective fault current, next one down, it's got number 2 next to it, and that's got by inquiry or by measurement. Now we could do by inquiry, and you would contact the electricity company if you didn't have the paperwork to hand from the designer, and they would quote you the maximum available for your earthing system compared to your incoming supply, and they will always quote you the biggest figure available. It is probably unlikely to be anywhere near that, so it might be best to measure it. I have done a video on producing this, and there's a QR code that would take you to it. It's only me, I was just playing. Now if you're watching this on your phone, good luck on doing your QR code, but if you search prospective fault current and ZE measurement on the Sparky Help, I'm sure you'll probably find it. So let's look at our details that we had, and right down the very bottom it says PFC, the testing procedures for fault currents were PFC is 851 amps and the PSC is 844. So which of these two are we after? Well, actually we're only after the largest value, so it's 851 is what we're after. So these are the values that are being given, so it's in Ka, so we're going to put 0.851 kiloamps. Next one down, external earth fault loop impedance. Again, This is number 2. It says by inquiry or by measurement. Again, if we inquire to electricity company for your incoming supply and size of supply, they would quote you the maximum. And in the UK, for a 100 amp supply, a TNCS would be 0.35. Incidentally, the fault current for a single phase installation, 100 amp supply, they would quote you 16,500 amps, thereabouts. So as you can see, it's dramatically different. So let's see what we've got. And on here, right at the bottom, it says, and we can see down here, it says ZE is a 0.27 of an ohm. So that is what we can put in. So 0.27 of an ohm for our ZE. ZE, remember, is line to earth value back to the star point of the transformer. Watch the video on how to do it if you're not sure. Next one is fuse size. So the incoming fuse, so that's the bit in the service head, the grey bit that was on the picture earlier on. And if we look there, in the incoming supply, which is down here, is 100 amp BS1361 type 2. These, if you're putting new installations in, they don't make a BS1361 anymore. It's now a BS88-3, which has replaced it. There are slight changes in the values that they have, but it's practically the same fuse. I was looking up on these, and the wording they use, it's for non-skilled people who should be ordinary people who should be using them. I don't know what ordinary people are doing using them, but that's what they're supposed to be for. That's what they're made for. So BSEN, it's a 1361. It could well be different. It could be a BS88-3. In this case, it says it's a type 2, so type 2 is what we put in, and the rated current of it is 100 amp, which is a fairly standard. If we carry on working our way down here, we can see we've got supply polarity. Now, if we've got all of these things up here, the chances are our supply polarity was okay if you carried out a fault loop impedance prospective fault current, because the meters generally have polarity built into them. So we can tick that one. Other sources of supply, as detailed on attached schedule. So other source supplies, you've got a wind turbine or solar panels or generators or anything else like that is powering back into your system or back into the grid, whatever it happens to be, probably both. But if we haven't, then it's either an NA or just leave it blank. I tend to leave it blank. Moving on down, particulars of installation, we've got earthing means, and we've got the distributors facility because it's a TNCS. If it was a TT, we would be sticking earth electrode. We may well be putting earth electrodes in more and more. We don't know. We'll wait and see. Going across there, maximum demand. We need to go back to this, and this would be go back to the designer, because maximum demand is a very contentious issue in most cases, unless we've all got smart meters, by the way. And if you've got a smart meter, watch out for this hourly billing and all the rest of it that's been coming up and will come up and probably become more prevalent over the years as people transfer over to them. So in this case, we've got look at what the designer has given us, and it says the maximum demand has been assessed by the designer to be 38% of the incoming supply. So that's nice and simple. It's a 100 amp one. This is just information we're given, so we've got to put something in, and we're going to put 38. Now we've got a choice now of kVA or amps. Well, we started off in amps, so it says delete as appropriate, and I would always stick with amps, I must admit. So that's what I would go for, because in kVA you're looking at about 12 kVA for a 100 amp supply, there or thereabouts. So we're going to go for 38 amps. What it isn't supposed to be, you're not supposed to be putting in 100 here, because what you're basically saying, if you put 100 in here, you're saying the maximum demand of the entire installation is 100 amps, which means if I was to come back in a couple of years' time and they said I would like to put an electric vehicle charger in, I'm going to ask for the previous test sheet, and I will look at your test sheet and I will see that you said it's 100 amp as a maximum demand, and I'm about to add another 32 amp supply to it. My conclusion would be, based on your assessment or the assessment that the inspector has done, and say that the incoming supply is not big enough, and therefore I would have to go back to the electricity company, or send the client to go back to the electricity company and get an upgrade of supply. So beware of that. It's not supposed to be a transfer of the fuse rating to that down here, because very rarely is the maximum demand that high to the rated fuse. You're basically saying it's at maximum capacity. It's surprising how little we actually use. So if you do come across the said smart meters, It recalls all lots of information. Go back to the actual meter itself, not the remote box, because I'm not sure they all do it on that, but back to the meter itself, there'll be a button on it you can press, and you can cycle through, and you can see information like volts, amps, power factor even, but also kVA, amps, and maximum demand available in there. So you can tell, and it would be accurate. Obviously, the longer it's been in, the more accurate it would be. So we put something in for maximum demand. It's an assessment. It's your assessment in this case. Details of installation earth electrode, but we've just said there aren't any, so we won't bother putting anything there. So that's not applicable. Now the next bit talks about is bonding and cable sizes and earthing conductors in general. Bizarre, isn't it? We don't put the size of the tails in. Obviously we've put it in here, but we've got the earthing conductor is a 16mm, and we have main protective bonding to the water and gas, which are 10mm, and they're all copper conductors. So let's see what we can do. Earthing conductor, the material is copper. The size was 16mm. The bonding conductors was copper. The size was 10mm. What did they go to? Well, it said it water and the gas. Now, if we did a ZE, it means we must have verified its connection, because if we didn't get a ZE reading, then you would not have had a connection, and therefore that would prove that one to be wrong. We're going to assume that main protective bonding has been done. I'm going to get around to doing a video on that, but basically what you'd look to do is remove the earthing, the main bond conductor from the MET, and measure long lead test from there to the pipework, or whatever it is, the extraneous conductive part that you happen to be bonding, and we'll tick it because it's your first dead test that you tend to put in, so we'll tick that one. Moving on down the sheet, we're getting our way through now. It says main switch, switch fuse, circuit breaker, or RCD. These are all your main disconnection points of the installation, whatever they happen to be. So the first thing to ask for is the location, so we need to go back and look to see where it is, and we can't just say in the disk board. We actually physically want to know whereabouts is it. Is it the cupboard under the stairs? I don't know. Most convenient place if ever to put one. The main switch is installed in the garage and is shown in figure, and is shown in figure 2. I'm not going to bother showing figure 2. It's in the garage, that's all we need to know, it's there. However, I will show figure 2, i.e. what the actual isolator looks like, and there it is. So we need information off of it. Okay, so we've got it there, nice and large, we can see it. The BSEN number we can see on the front, it's 60947-3. It's a fairly standard rating for switch disconnectors. How many poles? Well, there are 2 poles, and that's what you'd expect for a single phase installation. So 2 poles goes in there. Moving over to current rating, and we can see the current rating is 100 amp. Now, everything we tend to put on these sheets is there for a reason. So 2 poles, you'd be checking against your earthing system and your supply voltage, making sure 2 pole was enough, because it could be a 3 pole, 4 pole, if you're talking 3-phase 4 wire, and depending on the earthing system and checking against the regs could determine whether that particular device was correct or not. In this particular case, our current rating is 100 amp, which coincides with our 100 amp up here. So if we had a 160 amp fuse, we would be wanting a 160 amp main isolator. Otherwise, it wouldn't be capable of doing the job. So that bit is check, fine. When we go to fuse device rating or setting, well, this particular device is just an isolator, so it's no different to a light switch in that sense. If you get a fault on a light, the light switch will not turn off. This would be no different, so it doesn't have a fuse device rating or setting, so that gets an NA. Because if we look back here, it said it could be a switch fuse or a circuit breaker, and obviously they would have a device rating or setting. The next one down, voltage rating, that does have a voltage rating, and we can see up there it has a value of 230 volts. Again, this would be checked against your standard voltage up here. Not that I don't think you could put one in that was 50 volts, but if you did find one that was 50 volts, you'd want it to be at least 230 volt rated, because that's your supply voltage. Likewise for 400 and so on and so forth. So that's our voltage rating sorted. The last bit on there is if the RCD main switch. So this is not an RCD, but if it was an RCD, you could put the current rating of it. So that's the I delta in, that's the residual current rating. So that would be 30 milliamp, 100 milliamp, 300 milliamp, 500 milliamp. You get the idea. Next one is suitable time delay, because if you've got one in a TT, you may have other RCDs in line, and therefore you're going to make that one a time delay, and you'd be looking for the manufacturer to quote what the time delay is, because they might say 50% extra of whatever the disconnection time happens to be. And then we've got the measured operating time. If it happens to be an RCD, obviously you would then test it with an RCD tester to see how many milliseconds it disconnected in the most onerous of the times that you then check it. In our case though, we don't have one, so they are NA. Next bit down to the bottom of the page, it says schedules are attached. And these are the two documents that get handed in with an electrical installation. They are the schedule of inspections and the schedule of test results. And basically you have to insert in here how many of each go in. So we've got one schedule of inspections, and we've only got one distribution board in our made-up example, so we're going to put one schedule of test results. In a building, large building, you could have many schedule of test results because you may probably going to have one per board, so that would be a large number. So what does the schedule of inspections look like? Not that this is the video for this, but that's it. It's the tick box. Apparently the chances are this is going to be shortened down for the new regulations. But in here we are basically looking to put in either a tick or an NA against anything on the description that is relevant to the project or installation that you are inspecting yourself. Schedule of test results, we've looked at this before and we've covered little bits of this on other videos. But we'd be looking for information to go on here for your circuits. If this distribution board was at the origin of the installation, which is where we just were, then obviously the distribution board reference number would be whatever it happens to be. So it might be DB1. The location would have been garage. The Z at the DB would actually be the same as ZE in this case, and the fault current would be the same as the fault current at the origin. So the values that we've got on the previous ones would actually go here. Confirmation of supply polarity would have been ticked as well because we've done it. Had it been single phase, then there wouldn't be no phase sequence. All the rest of the information would then be covered by your normal inspect and test. So I hope this has been useful. Please like and share and subscribe to this video to help me keep them going. Many thanks. Bye.